Example 8. Hey, you know what we haven't had?
Lunch.
True, but I meant a code word.
Code word lunch.
Okay. So, code word lunch.
Man, lunch.
I think I've just lost Mr. Hazelwood to lunch. All right, example, but as long as he doesn't lose his lunch. Okay. Describe how to transform the graph of y equals log x into the graph of the given function. Sketch the graph by hand and support your sketch with a graphing
Some lunch.
calculator. Do you mind?
What's the matter?
We need to.
Did you want something?
No, I'm good. We need to finish the video.
Oh my God. I don't know whose that was, but it's really bad.
Okay.
I'm not hungry for lunch anymore.
All right, so this is negative on the outside is reflecting across.
The x-axis, because anything outside of the function is going to have an impact up or down.
Okay, and there's a vertical stretch of 2.
Yes.
And the negative on the inside means that it also reflects across the y-axis.
Right, so you have to really pay attention here or you're going to wind up in some sort of wacky place. I mean, it's true. I mean, you don't want to wind up in a wacky place graphing a logarithm.
No, you don't. So we want to remember, if we're sketching it by hand, then we want to think about, okay, well, what does the logarithm do? It does this deal.
Right.
We want to reflect across the x-axis.
Right.
And so this time the order should not matter because we're not doing anything that's going to affect something else negatively.
Right, because we're just flipping.
Right. So we are reflecting across the x-axis, so that makes it do this.
Right.
Going to take that and vertically stretch it 2. That means it just is wider, right? And so mainly this is what's going to look different.
Right.
Okay, and then...
And with a logarithm, a vertical stretch is sometimes not very noticeable, just because it grows so slowly.
Right, absolutely. Reflect across the y-axis now, so that flips it this way.
Flip
and so
pinky.
that means that, let me find my last color here.
Flip the pinky.
That we will still be...
Go through -1. That's important.
And so it should look most like the pink graph.
There you go. That's pretty good. That's not bad, actually.
And you don't have to graph all those steps in between. I just think it's easier to think of if you do the steps in between.
If you can see them.
Yeah, and if you can just jump straight to the last one, that's fine. Whatever you got to do what you got to do. You know what I'm saying? All right, so.
All right, coming up. This one's a little trickier here.
Oh my. Okay, so what have we got? We've got I'm going to start from left to right. We reflect over the x-axis again because there's a negative out there on the outside. We have a vertical stretch
by 3, so it makes it.
And then we have on the inside shift left of 1.
Yep.
Which we want to do before we reflect.
Right.
Over the y-axis. And then last we shift up 2. And the part here that's the kicker is this right here.
That's where the trickeration can occur.
I think I just said shift up 2, but that's totally shift up 1 because that's a 1.
That's totally a 1.
That could have completely thrown us off.
But it might not have. Let's graph this sucker and
get your elbow out of my face.
Getting really hungry too, K. Steve.
Don't open that again.
Look at the date on that. Whose is this? October 3rd, March 13.
Just leave it alone.
A year old. It's been in my fridge a year. I don't remember putting it there.
So this is what our normal logarithmic graph looks like. Let's go ahead and do the shifts. Let's shift up 1 and left 1, which puts our point here.
Right.
And then we're going to reflect over the x-axis and the y-axis.
Right, a little reflective action.
So when we reflect this way, It just makes it point this
The other
direction.
direction.
Let me draw that.
Yeah, draw that.
So that's.
So it's going to be.
Well, that was a little. And that's with
that's
the
a little
vertical stretch too.
That's all,
one
yes.
reflection, and then we got to reflect down.
Right.
So that puts our point down here.
Now it just reflects right over that spot, I think.
Over that spot.
Yeah, right there. Just reflect it right there. You're perfect. Everything's perfect. Now just reflect.
But
right there. Just go. Go for it. There it is. Ready? Go. And anytime now. Anytime. Yes. Yes. There you go. Good. And there you go. There it is. It's what the graph. That's what the calculator says.
okay, so that blue graph is your last one. Okay.
It's your last one. Okay.
Sorry. So this all being done with, this is like the most complicated we could get, just about, right?
Yeah, and it took us some
time, some thought, some effort.
Yeah.
They won't all be like that.
No.
But can you do 2 things at once?
Oh yeah, maybe even 3.
Maybe even 3, because that's going to be important. But you shouldn't
Right.
have to do 5 things at once.
No.
But be prepared for 2 or 3 things.
Definitely, and you can always use your calculator to help you out a little bit too, because
Right.
you'll start seeing some of the patterns when you.
Right, especially if it were to be on a no calculator part of a test.
Right.
It would be something really simple.
Yes, well, within reason, relatively.
Yeah,